Hello everyone and welcome to this week's video. Today I'll be explaining drag reduction system. It's the system used in Formula One, also referred to as DRS. So what is the purpose of a drag reduction system? Well, it's pretty obvious. It's to reduce the drag on the vehicle, and by doing that allowing it to travel faster on straightaways. So what's happening? Well, here we've got the side view of a rear wing, and as you can see there are two wings mounted in here, and so there is one that is adjustable, the one in red, and one that is fixed, the one that is black. So when you activate the DRS, this top wing rotates upward and becomes kind of parallel to the airflow. And by doing that it allows air to slip through this hole in the rear wing, and so you're reducing the drag, you're also reducing the downforce on the vehicle. So by doing that on a straightaway, you can accelerate to greater speeds, and Formula One claims that the cars can reach another 10 to 12 kilometers per hour by the end of the straight using this DRS system, and that it reduces drag by about 5%. So, how does it work? Well, the old system had a central pillar that was in the center of the vehicle that went up to the adjustable wing here, and so using hydraulics it would lift that up or down on these pivot points. Now, that system, they kind of went away from this system because this would kind of create a turbulent section underneath the rear wing, and that wasn't desirable. So some of them have moved on since then to other methods, one of which uses this sort of pod that you can see here, and this is mounted on the fixed wing. So this pod is responsible for lifting the adjustable wing up and down when you activate the DRS. Now, I couldn't find any images of what the inside of this looked like, so I don't know exactly what's happening in there, but I can give you an idea of what they're probably doing. So they probably got some sort of actuator which is inside of this, and that actuator will pull a line that's linked to the bottom of the wing, and it will pull it up and then let it go down or push it down. So how does it do that? Well, I just kind of drew a couple options here of what it might look like inside of this pod. You could have the linear actuator directly facing the direction it's pulling. So here it would just either pull the wing up or push the wing back down, and by doing that, lifting it up and allowing the airflow to go through. Or here is just a different idea, and it can be in any arrangement, but you've got a linear actuator which is connected to a cable, and that cable goes around this little pulley here. And so this can move in or out of this actuator here, and while it does that, it would pull this cable up, and then the downforce that remains when you are still, even when the wing is lifted up like this, it's still going to be producing a small amount of downforce. It might not even be that small. So point is, you can let the downforce alone push it back to where it needs to be, the drag, push it back down. So on that sense, you can just kind of reverse it and then allow it to go back down. So now you may be asking, all right, well, how does an actuator work, or a linear actuator? Well, what you've got going on is you've got a motor, and then attached to that motor, which it's going to be rotating, is this threaded rod. And so this threaded rod will have a nut that's going around it, and so as it rotates, it will force this nut to move in a linear fashion. Now, if the nut didn't have this guard around it, it would just simply rotate with the actuator. But since there's a guard and this nut has flat edges, as this rotates, it's going to force the nut to move along those threads. So it'll move forward or backwards. So that's what's going on in each of these. It would just be pushing that green section you can see here in or out. And so this green section could be on a bearing or something like that, so that it wouldn't actually rotate with the nut. It would just force one direction or the other. So that's what we've got going on with the DRS system. Some of them actually, they just get rid of this pod entirely and just put everything in the end plates, and so there's different ways of doing that. And one thing you may notice here is these blue lines coming in. These are the electrical lines to power these linear actuators, these motors, which are going to be activating the DRS. One thing I did not yet mention with the drag reduction system, this is only allowed to be used if you're within 1 second of the car in front of you and you're about to go onto a big straight, which the FIA has declared as a DRS zone. So if you're 1 second behind a car or less, say half a second behind, and you come up onto this straight and the FIA says go, you've got DRS. You can mash your DRS button. It'll pull that flap up. You've got less drag, and hopefully you can catch up to that competitor and then pass them with the extra speed that you're going to have, since you don't have as much drag as they will. So the idea basically is just to make it a little bit easier for overtakes in Formula One, make it so it's not so you just watch the same people in the same order go around the track the whole race.